Welcome to part 2 in our Globus webinar series on flows. I'm Greg Naraki with the Globus customer team, and today I'll be covering building and running flows. Building on the presentation from part 1 of this series, let's do a quick review of Globus flows. Flows is a Globus platform service for defining, applying, and sharing distributed research automation flows. Flows are comprised of actions that call action providers to perform tasks. In my presentation today, flows are initiated by human interaction in the web app, or as we'll discuss later, by command line or the SDK. We are currently working on flow triggers that start flows based on certain events, like the appearance of a particular file size change in activity, and other common mechanisms that instruments may use to indicate that analysis is complete and data is ready. In part 1 of this webinar series, we saw how to execute existing flows. For these flows, I believe you are briefly shown the definition of the flow itself and the input schema that frames the required user input for the flow. Perhaps you recall seeing a bunch of scary JSON. Our goal in this presentation is to make that JSON a whole lot less scary. Recall that the Globus Flow service is built on AWS Step Functions as a managed state machine service that has its own JSON-based state machine language. We use a subset of the state types of that language as well as extend it with our own states. In addition to actions, conditions, loops, and other common code structures are supported. In this presentation, we'll be constructing our flow from pre-existing action providers provided by Globus and available to anyone. Custom action providers can be authored using our API for integrating custom event and action services. Actions can be asynchronous, where the actions take place and move to the next state, or synchronous, where the action requires additional information, user input from a web form, for example, before proceeding. As is the case throughout the Globus ecosystem, Globus flows are secured with Globus Auth. This is true for both authorship and availability of the flows in the flows library, as well as securing the flows and their included actions when they are run. We'll see examples of this in our demos. Looking at the Globus ecosystem for automation services, in part 1 of this webinar series, we pretty much lived in that upper right corner, running existing flows. In this presentation, we'll be in the upper left corner as we define and deploy a new flow with crossover to the upper right to show the functionality of our newly authored flow. One might imagine a case where a laboratory manager tasks a developer with authoring a flow that can be made available to and run by other researchers in the lab. But things can be much less formal. I'm certainly no software developer. However, I find it quite straightforward to author my own flows to automate tasks that I need to repeat on a regular basis. As I mentioned in the previous slide and illustrated in the bottom of this one, custom action providers can be authored using our API for integrating custom event and action services. While that is beyond the scope of this presentation, I will reference the Globus Action Provider API specification documentation later. So let's jump in and create an example flow. For those of you familiar with other Globus tutorials, we'll be using a Jupyter notebook to walk through code examples. For those new to Jupyter, Jupyter notebooks are a way to execute code segments from the comfort of your web browser. Taking Jupyter one step further, Globus operates a Jupyter Hub, which provides a hosted execution environment for notebooks. This is advantageous for 2 reasons. First, when you run the code in the notebook, you don't have to concern yourself with the configuration of a local execution environment. Second, the hub itself can be secured with Globus Auth, and indeed this is the case for the hub that Globus operates. When using Globus Auth to authenticate to the hub, tokens and scopes for the various Globus services, including flows, come along for the ride and are available to those services without the need for exchanging an authentication code or other authentication mechanism. I invite you to follow along by pointing your browser at jupyter.com www.demo.globus.org and clicking the orange Sign In with Globus button. You will authenticate to our Jupyter Hub with Globus Auth just like you would when you log into the Globus web app. Next, click on the Globus Jupyter Notebooks link to take you to our collection of notebooks, and then the Automation Using Globus Flows notebook to launch an instance of the notebook. Everything I do in this tutorial can be gleaned from the documentation in the link at the bottom of this page. The example flow we'll be creating automates a common design pattern, moving data from one system to another and making the data accessible to collaborators. The instrument use case would be moving the files off the instrument to a high-performance storage system where they may be accessed by all members of the research project. It is a simple two-step or two-state flow that uses two Globus-defined action providers available to all Globus users. These action providers, called transfer and set permission, do exactly what one might think they do. We need to do some initial setup, including importing some Python code modules and setting the client ID of this notebook so it can use Globus resources that it has been granted access to. We'll also set the source and destination collections by UUID. As a data source, effectively our instrument in this example, we'll use the collection Globus Tutorial Endpoint 1, referenced here by its UUID, so we can access the three small text files in the Share Go Data directory as though they were files created by an instrument as a result of a sample run or similar process. As a destination, we'll use the collection Globus Tutorials on ALCF Eagle. This truly is a guest collection on a high-performance storage system, specifically built for data sharing and distribution at scale. The recipient of our data will be the tutorial users group. This is the UUID that we will use to grant read permissions on the directory we create with our specific flow instance on the Globus Tutorials on ALCF Eagle guest collection. This could certainly be an individual identity instead of a group. Jumping into our notebook, I'll execute this segment of code by selecting it and clicking the Run button in the top menu bar. First, I'll sign in with Globus. It may take a few minutes for a Jupyter Hub to start on your side. Click on our Jupyter Notebooks directory and then that notebook that we want to run. I'll scroll down and here's that first segment of code I'll run, and you'll notice that it completes. As previously mentioned, Globus flows are secured with Globus Auth. In order to access the flows service and author and deploy flows, one must have the tokens to do so. Since we've used Globus Auth to authenticate to the Jupyter Hub, the tokens we need come along for the ride. If you choose to run the notebook in your own environment, you'll have to get the tokens by a different method, such as a native app grant. The tokens we need are stored in a secure database in the Hub. When we run the next segment of code, we'll print those tokens and have a look. I won't dive too deep into the rest of this code segment. The pertinent result is an instance of the Flows client that we'll use going forward. Let's jump back to our notebook, run this code segment, and take a look at our tokens. Paying attention to this print statement, we'll select this section of code and run it. And we'll see here amongst the tokens that we have printed out, we'll see the token that our Flows client will use going forward. Since there are many of us that may be running this example, we'll want to tag anything that gets placed in a common resource, like the created directories in the destination guest collection, with our primary identity UUID. We'll also want the email associated with our identity so we can receive notifications. We'll jump back to the Jupyter notebook and execute this code segment. We'll select this segment of code and run it and see printed out our primary identity, the UUID associated with that identity, and the email address associated with that identity. So now we can get to the task at hand of actually authoring a flow. So there are 3 steps to authoring a flow: defining the flow with JSON, And recall that flows are composed of state types, and in this example, our two states will be our two action types. Defining the schema, that's some more JSON, but it's pretty standard. We'll see that. And then deploying the flow, which, thanks to our flows client, is just a simple method call. So we'll now demystify that first bit of scary JSON, the flows definition. The top level fields are right out of the Amazon State Language Playbook and are self-explanatory. Globus Flows supports the state types listed here. The first four are from the Amazon States Language Playbook. There are other states defined therein, however they are not supported by Globus Flows. The remaining states are Globus-defined states. The action state is the heart of our example, or the two hearts as the case may be, and we'll dig into that state type in depth in the following slides. The expression eval state is a method of evaluating an expression to create parameter values for passing to an action. It differs from the choice state in that the choice state type can only read single values from the runtime state of the flow. If the value which a choice condition needs is to be combined from separate parts of the flow runtime state, the expression eval state can compute a value that can then be referenced in the variable property of the choice. Let's dig into the action state type, starting with our first action, which will implement the task of transferring files from one collection to another. The name we'll give our action reflects that. All actions must have the type defined as well as a reference to the service endpoint of the action provider. Each action state optionally defines its own set of properties or inputs. Input to the action can either be by the input path or parameters properties. In this example, parameters are referenced from the input schema, which we'll see soon, but they could also be constants or expressions, which we'll speak to when looking at the next action. Rounding out the action state type, result path is a reference path indicating where the output of the action will be placed in the state of the flow runtime. The output return from the action includes the action ID, the final status of the action, the start time, the completion time, and of course the details containing the action-specific result values. Wait time, which is optional and defaults to a value of 300 or 5 minutes, is the maximum amount of time to wait for the action to complete in seconds. Upon execution, the flow will monitor the execution of the action for the specified amount of time, and if it does not complete by this time, it will abort the action. Next, or end, which are mutually exclusive, but one is required, indicate how the flow should proceed after the action. Next indicates the name of the following state of the flow, and end, with a value of true, indicates that the flow is complete after this action completes. Moving on to the second state of our flow, the one where we set permissions on the guest collection, you'll note that this action looks very similar to the last. It may be beneficial to mention that values and parameters can be specified in a variety of ways. Constants specify a value which will always be passed for that property. Constants can be any type, numeric, string, Boolean, or other objects should an action body specify sub-objects as part of their input. When an object is used, each of the properties within the object can also be of any of the types enumerated here. References copy values from the state of the flow to the name given. The name must end with the sequence $, to indicate that a reference is desired, and the string type value must be a JSON path starting with the characters $ and period, indicating the location in the flow runtime state that the values should be retrieved from. As was the case with our previous action, many of the parameters are referenced from the input. Expressions allow values to be computed as a combination of constants and references to other states in the flow's runtime. This provides a powerful mechanism for deriving parameter values. We'll jump back to our notebook and run the section of code that defines our flow. We'll select our code segment and run it, and you'll notice it successfully completes with no output. While excellent examples, the two actions that we presented are not exhaustive when considering the features and functions of this state type. We have excellent documentation on the action state in its entirety. Globus action providers provided for all to use, and details on authoring your own action providers. The second part of authoring a flow is to define the schema for required user input to the flow. This allows for per user or per runtime customization of the flow. Inputs we'll request from the flow user at runtime are details about the data source collection, destination or sharing collection, a Boolean state, whether a single file should be transferred or the recursive transfer of an entire directory should be implemented. The flow user will also be prompted for the identity type and the identity UUID of the receiving individual or group. We define those input properties in the first part of our schema JSON. Digging into the details of our first property, the source collection, we can see a pretty standard JSON format and name value pairs. The exception would be the Globus collection format type. Since Globus collections are often the foundation for many flows, this custom format type is quite convenient and is well documented. The other properties of our input schema are similarly defined. We'll switch back to our Jupyter notebook to run the section of code that defines the input schema of our flow. As before, we'll select our code block and run it, and it will complete with no output. Thanks to the Flows client, deploying our flow is trivial and straightforward. Back to our notebook. Before we run this segment of code, we'll note that the flow is going to be given a name of tutorial-transfer-share followed by a unique UUID that's going to be generated, and this ensures that all of our flows don't have the same name because many of us are running the same demo here. And we're also on the output, there's some print statements here, and we're going to see the flow ID. This is going to give us the UUID of the actual flow, as well as a URL that will take us directly to that flow in the web app. So let's go ahead and run this code segment. And sure enough, we get the output with the successful deployment of our flow and the UUID of that flow. And then we're going to click on this link, and that's going to take us directly to the web app where we can see our flow right here. One item of note is the section that was commented out in the last block of code we ran. If you make any changes to the flow, you'll need to update it. That step is very similar to the step we used to deploy the flow. Note that you can make other changes to the flow when running the update method, such as changes to the flow roles for various identities. From here, we'll switch back to the Globus web app, as this will probably be the way that most view, manage, and run their flows. In the top level flows menu, by clicking on the library tab, we can discover all of the flows that are available for us to view. Indeed, we see the flow we just deployed right here at the top. If we click on the definition tab for our flow, we can see the definition of our flow, and we can see the input schema for the flow we just defined and deployed, and nothing should be a surprise there. And if we click on the roles tab, we can assign roles so we can make our flow visible to others, either other identities or other groups, runnable by others, or even administered by others. So this is a way to share your flows with other people. Okay, so let's go ahead and run an instance of our flow. We do that by clicking on the Start Flow button. And here's that authentication step where we need to consent to running this flow with our identity. And we'll go ahead and do that. So recall from our input schema that we had some inputs predefined to some default values. And so our source of data is going to be Globus tutorial endpoint 1, and this is in our instrument use case. This is mimicking our instrument. And there are 3 small text files available in the share go data directory, so we'll set that. The destination for our data is going to be Globus tutorials on ALCF Eagle. That is a guest collection that's been set up, so we could use it in a high performance file system. And we're going to put the data in a directory called automation-tutorial with the UUID followed by -shared.files. And that UUID is the UUID of our primary identity. So that's the transfer step, and we're going to indeed do a recursive transfer, so we transfer all three of those text files. So recall the second step of our flow is sharing, and we're going to share with a group. In this case, we're going to share with the Globus tutorial users group, and this is the UUID of that group. And remember, those were all predefined in our flow. So I'm going to label this run, and we'll call it instrument group share, for lack of a better string, and we can give it some tags to add to the run so we can search on it later, and maybe we'll just call it instrument transfer share, so it will search on any of the part of this string. And let's go ahead and run the flow by clicking on Start Flow. So as our flow is running, or after it is run, we can go ahead and view some of the run details for that flow, including the event log, so we can see what's happened with our flow. In this case, our flow started, the files have transferred, the permissions were set, and the flow has succeeded. So let's now see the result of this flow. If we click on File Manager, and let's look at Globus Tutorial Endpoint 1 in the share Go Data directory. Recall that there are those three small text files that we're going to transfer. And if we go to Globus Tutorials on ALCF Eagle, recall the automation tutorial directory, and then we're going to have to look for our identity. This happens to be the UUID of my primary identity, -shared-files. And if I click on that, we indeed see those three small text files that were transferred there. Now, let's see who that was shared with. If we click on that file, that directory, and we click on the little sharing icon, we can indeed see, and again, we're going to have to sift through here and see, here's that directory that where my three small text files were, and we can see indeed it was shared with the tutorial users group. So our flow was successful, and here's the fruits of our labor. And the instrument use case this represents, moving data off an instrument up to a high performance file system where they can be shared out with users, or in this case, a group of users. Back in the main flows menu here, we can see that flow that we just ran, named as we had just named it. You can click on that. And again, we could go back and look at the event log, or in the roles tab here, we could actually assign roles to that flow run. In this case, we can give others the ability to monitor the flow run, or even manage the flow run should something go awry and you wanted somebody else to be able to cancel that flow. Flows may also be run directly from the API. Section C of the Jupyter Notebook details this. The steps required reflect the same process we experience when running the flow from the web app and are presented in three distinct code blocks. First, we'll need to authenticate with our identity to run the flow. Instead of an automatic redirect to grant consents, the notebook will print a URL which must be copied into a web browser. This will then present the consent menu, and upon granting consent, an authorization code will be displayed that must be manually cut and pasted back to the notebook. Next, we need to define the flow input parameters as required by our input schema. This is a JSON document, which should look pretty friendly at this point, especially when considering the JSON of the input schema. Last, we run the flow, which again, thanks to the Flows client, is a trivial step. There is even an example in this code block of how to poll the flow service to check on the status of the flow. I won't walk through the process here, but invite you to try it on your own. Flows may also be run from the Globus Automate command line interface. Actually, flows may be defined and deployed from the command line interface as well. For those familiar with the Globus Transfer API and the Globus command line interface, you'll recall a near one-to-one correspondence between the commands of both. That tradition continues with the Globus Flows API and the Globus Flows command line interface. The definition and deployment steps that we showed in the Jupyter Notebook could be just as easily executed via the Flows command line interface. Using the Flows CLI requires installation of the Globus Automate client, and there is excellent documentation on using the CLI as well as a complete command line reference. All of these docs are called out and linked to from the high-level Flows document referenced at the bottom of this slide. Since we haven't yet experienced the Automate command line interface, let's jump over to that CLI and run another instance of the flow we deployed earlier. So I've previously installed the Globus Automate client, so I can go ahead and run the Globus Automate CLI here. And just like the standard Globus command line interface, it's got hierarchical and contextual based help. So if I run Globus Automate help, I get a list of commands here, and we're going to want to run a flow. So I'm going to look for flow help on Globus Automate flow help, and I get a list of commands associated with Globus Automate flow. And the first thing we'll want to do is go ahead and list the flows that are available to us. I'll list my flows, and here's that flow we deployed earlier, the tutorial transfer share flow. And here's the UUID that we'll need when we run this flow. So let's go ahead and run Globus flow run help so we get an idea of what we're going to have to do to actually run this flow. And here we see that we need Globus Automate flow run. We need the flow ID followed by the flow input. And this is just like when we were running it in the web browser, and we had to go ahead in the web app, and we had to go ahead and input those commands that we had previously defined in our input schema. And this is going to be a JSON document with the flow input. And again, this should look pretty familiar. So let's go ahead and take a look at that JSON. And I've got that here. Got my command somewhere here. There we go. Globus, I've got a text file, Globus tutorial transfer share input.txt. And you'll notice here it's a JSON document that again should look pretty familiar. I actually took this right out of that Jupyter notebook, so this should be pretty familiar here. Modified it a little bit, so this input ID is again Globus tutorial endpoint 1. This is the share Go data directory on Globus tutorial endpoint 1. The destination, that contains those the 3 small text files. This is the destination of our transfer, and this is the guest collection on ALCF Eagle. And the path that we're going to put those files in, those 3 small text files. And you'll notice I've modified this just a little bit. I put CLI, the text CLI in here so we can see that when we actually go see that on Eagle. We want a recursive transfer. We want all 3 of those files to transfer. And again, we're going to share with a group, and we're going to share this with that Globus tutorial users group, and here's the UUID of that group. So again, this should look pretty familiar. So our instrument use case is this represents our instrument, this collection here, where the data is going to be available after whatever run has occurred of this instrument. We're going to transfer the file up to our high-performance file system so other researchers then can access that data and retrieve it. And this is the group of researchers that is going to access that data and retrieve it, in this case the tutorial users group represented by this UUID. So here's the command we're going to use to actually run that flow, Globus Automate flow run, followed by the UUID of the flow that we saw when we did Globus Automate flow list, followed by the flow input option, which of course has the path and file name of that JSON file for our input for the flow. Followed by the label option and a name for the flow, the name for the run of this flow. You recall from the Globus web app we use Globus Group Share. I'm just going to run it with Globus Group Share CLI in this case. So let's go ahead and run that. When the flow runs, it'll give us some information here regarding the run, and we can certainly use the command line interface to query the run and see what's going on. But let's just jump over to the web app to see how it has run and what the result was. So returning to the Globus web app, in the Flows menu, in the Runs tab, we see the run that we had just executed from the command line interface here, named as we would have expected it to be. And if we click on that, we can dig into the this particular run of this flow, look at the event log. We see that everything happened as expected. We can jump to the file manager. Here's our destination collection, that guest collection on Globus tutorials on ALCF Eagle. Here's that directory we created with the CLI shared files at the end. If we go in there, we see the 3 text files that were transferred from our sudo instrument. Returning back a level, we can see that that directory we created has been shared with the tutorial users group as expected. I'll leave you with pointers to our documentation, including the flows specific documentation, where you can find information about everything that we did in this presentation. Thank you for watching.